Hi, my name is Dave Lannom with Monroe Training, and welcome to today's segment on Introduction to Circuit Faults. Let's go through our agenda real quick. We're going to talk about why we're talking about circuit faults. I want to introduce you to the four circuit faults. I want you to be able to identify which circuit fault exists in a circuit, the diagnostic process for each one of those, and tying it all together. So, why circuit faults? I mean, if you piece all the pieces together, whether it's basic Ohm's law or basic circuit construction, remember this. No matter how complex the circuit becomes, it still only has three parts: a source, a load, and a complete path for current to flow. With only three parts and the fact that it can only fault in one of four ways, being able to identify the type of fault is the first and most important start of testing. Remember, a diagnosis is the result of multiple tests. And by understanding the type of fault, we can quickly perform the correct test to identify the root cause of any problem. So, what's the $1 million question? What are the four circuit faults? And they're this: any fault that you have in a circuit is going to be one of four things. It'll be an open, a short to ground, a short to power, or excessive resistance. Now, there are some people that'll insist that an intermittent is actually a fault, but it must be an intermittent of one of the above. So, intermittent is really the adjective to an intermittent open or an intermittent short to power, intermittent short to ground. So, with that said, let's talk about those four faults. And we'll start with an open circuit. And by definition, what's an open? It's an incomplete path of power or ground to the load. It's a symptom that it doesn't work. The component's not operational. And in this particular case, with an open circuit, the fuse never blows. Why? The fuse blows when it has excess current. And with the absence of a complete path for current to flow, there is no current flow. So at that particular point, it won't blow the fuse. You have to remember, an external force has to act on the circuit to cause the open. And we'll talk about that more as we dive deeper into each one of these faults in future modules. But let's take a look at the symptoms of an open circuit. So what's our second fault? Our second fault was a short to ground. And the first thing we had to define is, what is it? And short to ground, by definition, is simply an unintentional routing of power to ground. In most cases, the component's not operational. In the case of ground side control, the component continues to operate. And most frequently, just like we said in most cases, it's going to blow a fuse. And on the must remember side, you have to remember when the fuse blows tells you where the circuit fault is located. And once again, as we explore deeper into shorts to ground, we'll be able to go through some of those testings and that process. But let's see what a short to ground looks like. So we've got two of the four. So let's talk about a short to power. And just like a short to ground was an unintentional routing of power to ground, by definition, a short to power is an unintentional routing of power to power. In most cases, you turn on one component and two components operate. For instance, if I turn on the headlights and the wipers start to work. Now, there are times where a short to power is misdiagnosed as a short to ground because when we actually added the second load to that same circuit, it exceeded the fuse's rating. But once again, just like a short to ground, we have to remember that wires left undisturbed seldomly fail. And again, we'll take that into much more detail as we begin to discuss how to diagnose these four faults. So we've got three out of four. What's the last one? And the last circuit fault is excessive resistance. Just like every other one, let's define it first. And by definition, excessive resistance is nothing more than unwanted resistance in a circuit. Most frequently, it results in a voltage drop, causing a lack of power at the load. Remember, when we talked about electrical laws, we talked about power. And when we create a voltage drop, there's less power available at that load. And as a result, there's less wattage available. So, what are the symptoms? Lights are dimmer, the fan turns slower, the windows raise slower. In some rare cases, there's enough voltage drop is created to cause a component not to function at all. And on the must remember side, remember the most likely cause is corrosion, or I'm going to introduce a new term. It's called conductor asperity. And in this particular case, you can see there's a microscopic view of a conductor. And the black areas are where there's actually contact between the connector and its terminals. And the white areas are where it doesn't connect. And remember, the smaller that pathway becomes, the more resistance and the resulting voltage drop at that particular point causes excessive resistance. And here's what it looks like at the car. So, in summary, by keeping electrical diagnosis simple, we can reduce any issues to the three core components: the source, the load, or a complete path. Remember, those three components only have four faults, and the faults have their own symptoms. Now, coming soon, we'll dive deeper into diagnosing each one of the four circuit faults. Hope this introduction has been helpful for you. I look forward to seeing you in the first segment on how to diaggnose short to ground. Thank you and have a great day.